Thank you, Ishtiyaque. So yeah, so there was a discussion in Slack about what was the correct pronunciation of the paper's name, which I will not pronounce again. I'm too embarrassed now. And so let's move on to questions instead. So if you have a question, please either post it on Slack or raise your hand and you can ask it. I think Shudong, I think you also had a question on Slack. Do you want to ask it?
Yes. So I'm just wondering whether the documents are all immutable. If the size of the largest document changes, like because you are doing the padding, like do you need to rerun all the bin packing and then recompute the location of every document? And would that be expensive?
Hi. So yeah, I mean, the documents don't necessarily need to be immutable. But yeah, I mean, updating them might be a bit expensive at times. So what we could, we actually don't discuss updating our paper, but what we can suggest is that updates can be in batches so that they don't occur very frequently. And we can actually keep some cushion for each document. I mean, if some documents are not like that frequently updated, so that it doesn't mess up with the bin packing that much with minor updates.
I see. Thank you.
And I believe Edward has a question. Edward, do you want to ask it?
Yeah, so this is really cool. And it seems like one of those by itself could already be a paper. And I just noticed that the end-to-end latency you report might even be a little bit pessimistic, because in this 3-round protocol, the idea is first the user interacts with the metadata server and gets the search results page. At that point, the user needs to look at the search results page and decide which document they want. So the interactive latency is really just the time between when they initiate their query and when they get the search results page, and then they experience a separate latency for clicking on a document in the search results page and actually getting that document. So am I right in guessing that? Are there actually kind of 2 separate interactions, and what are those 2 separate latencies?
You are right. So I mean, you can break down the latencies into 2 parts with even smaller latency for interaction. So what we report the 3.9 second is like sending the keywords and then receiving the final document, But yeah, I mean, in from interaction point of view, I mean, maybe it's a bit more interactive, you can say, if you think of 2 separate interactions. Yeah.
Right. So like, what's the time between when the user issues the query and when they see the search results page?
I think it's around 2.8 seconds for the first round.
Okay, that's great.
Thanks.
All right, so I have a bit of a philosophical question just to follow up on what Edward just said, which is the original protocol, you send keywords, you get back results. In this protocol, you send keywords, you get back a search page, and then the user has to go through the search page and then pick whichever one they want, and they actually get the object that they requested. So I wonder if there's some kind of timing side channel based on how long it takes the user to actually click on the search page, in the sense that if you have the results are very close together because they're highly ranked together, then you might actually be able to pick the best result very quickly. And so the adversary might make the inference that, oh, maybe the ranking of the 5 results that I gave to the user were very close together, or sorry, very different. Whereas if the user takes too long, maybe the results were very close together. This is hard to analyze because it's predicated on user behavior, but just a sort of a philosophical thought here.
Yeah, that's very right. And we actually assume that, I mean, client is not like exposed to side channel attacks because, like, I mean, as you said, there could be additional side channels, right? I mean, the time of the query when, say, something, there's hot topic going around and you search for something. So yeah, we actually don't kind of defend against these types of attacks, but in principle, you could do that, like, I mean, making everything constant, right? I mean, encountering, triggering the next round after a fixed amount of time, or sending dummy queries, I mean, very frequently. But yeah, I mean, those will be more expensive.
Yeah, no, that makes total sense. So I think if there's no other questions, I think we're done. We're done with the security session. So we had a flavor of some hardware security when we talked about Twin Visor. We had a flavor of some combination of hardware security and crypto when we talked about Snoopy. And now we had a flavor of crypto with some systems optimizations when we talked about the system whose name I won't pronounce. And so that's great. So with this, I think we're done with the session and we can move on to, I don't know if there's a break or if there's another session right after. Hopefully the organizers will correct me one way or the other. There's a break. I was told there's a break. So let's go take a break. Thank you all.
Very nice talk. So maybe let me ask the question to warm up this discussion. So I like the idea that you can actually change this 2-round protocol into 3 rounds. Even you increase the 1 round, right? You still get this improvement, which you decouple the metadata from the document, then you sort of fetch the metadata first, right? So my question here is that, do you think this decoupling will introduce some consistency issues between the metadata and documentation management? And also, do you think you also add some overhead to update both of them? Thanks.
Hi. Oh, so yeah, I mean, very good questions. So by consistency, do you mean like, I mean, the 2 libraries like inconsistently getting updated? Yeah, yeah, there is a slight chance of that. That's true. And like, I mean, so I mean, the way we can see it, I mean, just like non-secure system, I mean, non-private systems, when you search something and get a search result, and then again, maybe fetch that document. Meanwhile, that document can get updated. I mean, if you are very unlucky. So, I mean, the same thing will happen here actually. So yeah, but there is, I mean, a scope of inconsistency between these 2 libraries for a short time. That's true. And
okay, does the metadata include the address to the documentation?
Yes.
Okay.
It's location in the document library.
Okay, so that sounds like if you have incorrect information in the metadata side, then you cannot find the document, right? So yes. I think this decoupling idea is quite common in my area, which I work in the distributed storage, for example, like distributed file system, right? So because you want to scale the access from the massive users, then you normally decouple the metadata from data, right? So I don't know actually in this Oblivious storage part, whether they already leverage this kind of a modern style design pattern of the storage system or not. It sounds like they still use like this kind of a centralized storage, right?
Yeah, sort of. So, I mean, just to like maybe extend the discussion. So there is a slight chance of inconsistency, as you said. But the good side is, I mean, even then the privacy is not broken. So the client's preference and, I mean, which document is finally retrieved, that is not revealed. So that's the good side. And of course, yeah, there is a slight chance of being inconsistent. So the client might end up retrieving a wrong document. Yeah, that's true.
Hello. Yeah.
Hi.
Can I ask?
Please go ahead.
Yeah. Okay. Yeah. Thanks for the great talk. So I have a short question. So my question is, you mentioned the bin packing methodology that to reduce the number of the padding overhead, right?
Yes.
Yeah. So I wonder if the bin packing is performed for every time for each query separately, or if the bin packing is performed just once, and it is maintained through the multiple queries?
Yeah, bin packing can done only once, as long as the data is not updated. The same bin packing can retain. The bin packing may need to be done again if the data is changed.
So if the data is updated and if for example, the document size is changed, then the bin packing should be done again. And the location of the document can be changed by the reperformed bin packing, right? Then should the metadata or other data information should be updated together?
Yes, when the data is updated, I mean, all the libraries need to go through that update, I mean, some updates.
I see. So does it impose some high overhead, those update process? Yeah.
Okay, so I mean, conceptually, yes, but I mean, there are some ways to actually maybe mitigate the expenses. First of all, we can actually batch multiple updates together so that the amortized cost is reduced. And another thing is the bin packing. An optimal bin packing is NP hard. So what we did is applied a heuristic of best fit first. So that is pretty cheap, but that doesn't give the most benefit of bin packing. But for our case, it was within 10% of the theoretical lower bound. So that was comparatively cheaper. And another idea could be just to keep a bit of cushion for every document, so that for minor updates, you don't need to change the entire metadata, entire like bin packed system. Maybe just keep the same structure. So yeah, but updates require some operations. That's true.
I see. Thank you. Yeah.
Thank you.
Okay. So I also have another question. I would like to take this chance that this opportunity of being the chair. So the question is, the second contribution, or even like the largest contribution of the work, is this vector multiplication optimization, right? So
yes.
I don't know whether there is something very security specific, or it's the general optimization which can apply to this general problem. Yeah.
So yeah, I mean, it's very general. I mean, any system that uses secure matrix vector multiplication, where the vector is plain text, but the matrix is plain text, like the GFIDX matrix, and the vector is encrypted. So similar situation arise in many secure machine learning applications as well. So the same techniques actually can be used there as well. So this is kind of general, and the techniques are, I would say, more system-like than like we didn't change any core fundamental cryptographic techniques. We just reused some operations and identified some redundancies in operations and removed them by caching intermediate operations, and reordered some operations so that same operation can be amortized over multiple calls. And then finally we devised a partition mechanism, how to efficiently partition the workload. So these can be applicable in other contexts as well.
Okay. So there is one question from the Slack. It's made by Erhu Feng. The talk is about the question is about the PIR-like algorithm also have the scalability issue, right? That's the main problem that limits the PIR usage. How do you solve this problem? Yeah.
Scalability issue. So I mean, the main issue is like you have to process every bit of the state, and that was the largest challenge of the work.
Yeah.
So we actually didn't solve the PIR scalability per se. We didn't improve the PIR part that much. We mainly improved on the secure matrix vector multiplication part. And for the PIR part, we actually got advantage by splitting up the operations. Like, I mean, splitting up the round two into two smaller rounds. And yeah, I think that was the part. I mean, just reducing the data over which PIR needs to be run.
Okay, sounds good.
Does that answer the question, or like?
Yeah, I think the user can post the answer to the Slack thread. I think that's fine.